Assalamu alaikum dear viewers. My name is Amir Imtiaz and I am working as a physics teacher at Shah Rasool Memorial Welcan Educational Trust Sopor. In this video, we are going to discuss a topic, human eye and the defects of vision. This topic is a part of the syllabus of class 10th physics and is also included in the syllabus of class 12th physics. Therefore, this video tutorial will be beneficial to the students of class 10th and class 12th. Before taking off, I would request all of you kindly subscribe my YouTube channel, that's Amir War, and do not forget to press the bell icon for notifications of the upcoming videos. Alright, let's take off. In this video tutorial, we are going to discuss how exactly a human eye works, what are the various parts of which a human eye is made of, their names, their working, etc. And we are going to discuss what are the various defects that are caused in human eye, and we will discuss how these defects can be corrected and what are the various reasons behind these defects. Alright, let's take off from the very basic. A human eye is a sensing organ by which we are able to see objects around us. When light falls on different objects, it is reflected from them and it enters our eyes. An image is formed on our photosensitive screen called a retina that generates electrical pulses, and these pulses are carried by optic nerve to our brain, and thereby the brain processes the image, what exactly it is, and makes us respond. Okay, now the first part of our eye that's bulging out is a transparent covering that's called cornea. Cornea is a transparent covering that's almost bulging out. Okay, after that the second part that comes is a diaphragm, colored diaphragm, at the center of which there's a hole. The colored diaphragm is referred to as iris. Okay, and at the center of which there's a hole that's called a pupil, P-U-P-I-L, pupil. Okay, and the gap, or we can say the space between iris and cornea, is filled with a fluid that's called aqueous humor. Alright, when light enters our eye, first of all it reaches cornea. It suffers refraction because it has now moved from one medium to another medium. It passes through aqueous humor, it reaches the pupil. After reaching the pupil, it reaches the eye lens. That's actually a crystalline lens of variable focal length. Now I said variable focal length. How exactly we change the focal length of our eye lens? It is because of the ciliary muscles. You will be better able to understand the working of ciliary muscles with the help of nylon. You might have seen there are certain things that can change their shape, that can regain their original shape upon deformation. For example, if I tell you a spring, suppose a spring is compressed. Alright, it's compressed by a hand or it's compressed by some force, by a hammer. We observe that after some time the spring regains its shape. That's called the property of elasticity. In a similar fashion, if you take the example of nylon, okay, that we use in trousers, or we use in socks, or we use in other accessories, other garments, okay, these that nylon has got the property of elasticity. If it is stretched, it again regains its shape. That's called the property of elasticity. Ciliary muscles too have got this property. Actually, these are the organs. Ciliary muscles are responsible for changing the focal length of eye lens in order to make sure that a human eye is able to see both distant objects as well as nearby objects. And this property of eye is called as power of accommodation. I repeat, power of accommodation is basically the ability of a human eye to see distant as well as nearby objects. Okay, when we will move to the defects, to the defects of human eye part, we will discuss there that a particular lens of particular focal length is to be used for a particular person, but this lens, the crystalline lens that's in our eyes, has got the property that its focal length can be varied, but with the help of ciliary muscles. Okay, therefore we are able to see nearby as well as distant objects. Alright, after that the next part that comes in a human eye is after ciliary muscles is retina. Retina is a photosensitive screen. The image of the object from which light enters our eye is formed on this screen. That image, this screen actually consists of cone cells and rod cells. There's a spot that's least sensitive, that's called a blind spot, okay, and at which the optic nerve is connected to this our eye. The image that is formed is actually inverted, but our brain processes the image as if it is an erect image, okay. So these are all the parts of a human eye. Now we will discuss the working of human eye. One more thing you should remember here: the space between the eye lens and the retina is filled with another fluid that's called vitreous humor, okay. Now I will repeat it once. The very first part of the eye is cornea, second is iris. There's a hole in the iris that's called a pupil. The space between cornea and iris is filled with aqueous humor, and then comes the eye lens that's held in position by ciliary muscles that actually change its focal length in order to make sure that we are able to see both distant as well as nearby objects, okay. And then comes the screen on which an image is formed, which is a photosensitive screen. That screen generates electrical pulses. These pulses are carried to the brain via optic nerve, and the space between eye lens and retina is filled with vitreous humor. Alright. The working of human eye is very simple to understand. As I told you that an eye is a sensory organ by which we are able to see objects. Alright. When light falls on a certain object from any source, whether it's a luminous source or it's a non-luminous source, the light falls on an object. Alright. Suppose the object that we are talking about is a tree, and the light is coming from sun, okay. This light is reflected from the tree, okay, and this light enters our eye. First of all, it will enter the outermost part called cornea. Alright. It will suffer refraction. Again, it will move via aqueous humor and reach the pupil, that is the hole inside the iris, okay. After that, it will pass through the lens. Remember, you should remember one thing here, that maximum refraction that the light suffers is from cornea to lens. Lens actually has the main property of focusing the image on the screen. Alright. When the light has already suffered the maximum refraction, now the main function of lens is to focus the image on the screen. Light that came from a tree, which actually received its that light from a source like sun, okay, and now it has reached the lens. Now the focal length of this lens is varied according to the position of object. For example, if the object is too far, then accordingly its focal length will be adjusted by the ciliary muscles. If it is very near to our eye, it is focal length will be adjusted by the ciliary muscles. In a similar fashion, if we are at a place whether there is huge light coming out, for example, if you go out on and there is snow, you might have observed that you need to block a portion of your eyes. You don't need to keep full eyes open. In contrast to this, if you go in a room where there is dark, where there is less light, you need to open your eyes wide. Alright, all these activities are done by ciliary muscles. As I already told you that ciliary muscles have got the property that they can change their shape, they can regain their shape. They have got the property of elasticity, as I earlier told you, like that of a spring or like that of nylon, okay. These are the most important part of human eye, because it is there where defects arise. When these ciliary muscles lose their tendency to contract or to expand, defects start arising. I'll explain you later. As of now, just remember, the light that came from an object enters our eye through cornea, reaches the eye lens, alright, and an inverted image is formed on the photosensitive screen called retina. Now this retina generates electrical impulses, alright. These electrical impulses are carried to our brain by optic nerve. Then accordingly we observe the objects. Our brain interprets the information that has been sent to it by a sensory organ, okay, and then we respond. For example, if we see a car coming on a road, what happens? Light from car reaches our eyes, and it is our brain interprets the image that car is coming, and accordingly we move aside, means uh, we don't sit in the middle of the road. All right, in a similar fashion there are n number of examples wherein we realize that it is a sensing organ and accordingly we respond. So this is how exactly a human eye works. I will repeat in short. Light from objects of which the image is to be formed in our eye reaches our eye, and it suffers multiple refractions. First it suffers refraction from cornea, then it moves through aqueous humor, now again it moves it reaches the eye lens, that's a crystalline lens, whose focal length is varied by ciliary muscles. Now the main function of the lens is that it has to project that image on the photosensitive screen. All right, that is done by it, and thereby the electrical signals are generated that are carried to the brain, and brain processes the image. Okay. While discussing the working of a human eye, we observed that the image of the object should be formed on the photosensitive screen called a retina. Only then the image is processed by the brain, because electrical signals are generated by the photosensitive screen and they are carried by optic nerve to the brain, and thereby it is processed. Imagine if in case the image is not formed on the retina, it is formed beyond the photosensitive screen, or it's formed before the photosensitive screen, then we will simply say that the eye is defective. The very first type of defect that we are going to discuss is myopia. Myopia is such a defect of human eye in which it is able to see clearly the nearby objects, but it cannot see distinctly the far off objects. Means the objects which are located close to the eye, means they are nearby to the human eye, can be seen distinctly, clearly, but those objects which are far off from the human eye cannot be seen distinctly. How exactly this thing works? There can be two possible reasons for myopia to occur. The very first is high converging power of eye lens. I will explain you how exactly this can arise. And second reason is eyeball being too long. But most of the times I believe that it is the first reason that occurs. High converging power of the eye lens. I told you in earlier that ciliary muscles are the most important part of human eye. It is these muscles which adjust the focal length of the eye lens according to the position of object. That's called the power of accommodation. But with age, these ciliary muscles lose their tendency to regain the shape, to adjust the focal length of the lens, and therefore they are not able to continuously adjust the focal length, as a result of which in some cases a human being is not able to see the far off objects clearly because the converging power of the lens is too high. How exactly this thing works is that image should have been formed on the retina, but the eye lens cannot change its focal length because the ciliary muscles have lost the tendency with age, and therefore they are not able to adjust the focal length of the lens as image is formed before the eye, before the retina, sorry, and therefore this defect arises. Now how it can be corrected? It's a simple way. For this defect to correct it, we use a concave lens before the defective eye. We put a concave lens before the defective eye. The light coming from the far off objects is diverged from the concave lens, and it appears to the eye lens that the light is coming from a nearby object. Therefore it has to converge it more. When the eye lens converges it more, and the image is formed on the uh, photosensitive screen called retina. So in simple terms I will say, in a myopic eye, or in myopia, that short sightedness, an eye is able to see nearby objects clearly, but it is not able to see far off objects clearly or distinctly. The two possible reasons are that there is high power converging power of eye lens, or eyeball being too long. But most probably the reason that exists is high converging power of the eye lens. That is caused by the ciliary muscles that have lost their tendency to adjust the focal length of the lens,
and as a result, to correct it, we put a concave lens of uh, particular focal length according to the extent, according to the degree of defect. All right, prescribed by doctors, and therefore when we put a concave lens before a myopic eye, the rays are diverged. As a result, the final image is formed on the photosensitive screen called retina. In this way, myopia is corrected.
Like we observed in a myopic eye, the image of the object is not formed on the photosensitive screen called a retina. It's formed before it. In a similar fashion, in a hypermetropia, or we can say in a hypermetropic eye, the image of the object is formed beyond the photosensitive screen called a retina. Hypermetropia is such a type of defect in which an eye is able to see clearly the far off objects which lie at distance, but it is not able to see clearly the nearby objects. It is in contrast to that of myopic eye. Alright, hypermetropia is simply the reverse of myopia. The reasons of hypermetropia are the reverse of the reasons of myopia. The correction of hypermetropia is the reverse of correction of myopia. How exactly this thing works is that the two possible reasons of hypermetropia are low converging power of eye lens or eyeball being too short. I told you that the most important part of human eye is the ciliary muscles. It is these ciliary muscles which adjust the focal length of the eye lens, and thereby we can see nearby as well as distant objects. But with age, the ciliary muscles lose their tendency of adjusting the focal length because they are similar to that of nylon, or we can say spring. There's a concept in mechanical engineering that's called strand hardening. This is a deep concept. Probably you won't be aware of this. It is similar to that of it in actually in this you will be able to realize that with if we deform certain objects multiple times, then their deformation becomes permanent. In a similar fashion, when the ciliary muscles keep on changing the focal length of the eye lens throughout the age, with age they lose the tendency. Therefore, they are not able to adjust it continuously. As a result, these defects arise. Now, in a hypermetropic eye, we observe that the objects lying at far off distance can be clearly seen by the eye, but those objects which are very close to the eye cannot be seen clearly. In this case, the nearby distance, which is normally 25 centimeter for a normal human eye, becomes more than 25 centimeter, means it increases. So how can this defect be corrected is we place a convex lens of particular focal length prescribed by the doctors according to the degree of defect. That convex lens actually uh, assists the crystalline eye lens to focus the image of nearby objects on the retina. As we observed that in a hypermetropic eye, the nearby objects cannot be seen because the light coming from the nearby objects is of diverging nature. Therefore, when the eye lens has lost when the ciliary muscles have lost their tendency to adjust the focal length, the eye lens is not able to project the image of nearby objects on the retina. Now, when we have put a convex lens before the eye, the convex lens converges the beam of light coming from the nearby objects, and therefore it helps the crystalline eye lens to project the image of the nearby objects on the retina. In this way, it is corrected. So in simple terms, I will say hypermetropia is such a defect of human eye in which it is not able to see nearby objects distinctly, but it can see far off objects clearly. And it arises because of low converging power of eye lens or eyeball being too short. But the first reason is most probable. Therefore, it is now corrected by placing a convex lens of particular focal length before the eye. That's how it works. While discussing hypermetropia, I told you that there can be two possible reasons for hypermetropia to occur. But when the case is that with age the ciliary muscles have lost their tendency, have lost the property of regaining their shape upon deformation, or we can say have lost the property of adjusting the focal length of the eye lens with age, then that defect is called presbyopia, or I can simply say presbyopia is old age hypermetropia. It is basically a hypermetropia that occurs in old aged people, and thereby in which they are not able to see nearby objects clearly, because the focal length of the eye lens cannot be adjusted by ciliary muscles, because they have lost the elasticity, they have lost their elasticity with age, as a result of which they are not able to see nearby objects. But presbyopia, big eye can clearly see the far off objects. This defect is again corrected by using a convex lens. You might have observed in real life that if the plan mirror, like the one that is in our washrooms, is not of good quality or it is broken, the image formed in it is unusual. It's not of the same size or that it should have been. In a similar way, in cataract, what happens? The We know that eye lens is basically made of proteins, and there's a regular arrangement of proteins. Like we know that in case of solids, there are two types of solids. One is called amorphous, and the second is called crystalline. In crystalline solids, there is regular arrangement of constituent particles, whereas in case of amorphous solids, there is no regular arrangement of constituent particles. Glass is actually an amorphous solid. Okay, these things you are going to discuss in chemistry, probably in class 12th. So as of now, you don't need to worry about what amorphous and crystalline solids mean. I'm just trying to make you understand what exactly cataract is. An eye lens is made up of proteins. In some rare cases, these proteins get disturbed, means they no longer remain in a regular arrangement, as a result of which the transparency of the eye lens decreases, and this defect we call as cataract. There is no special tool by which we can correct the eye lens having cataract. We simply have to do what we simply have to do is that it can be replaced by surgical operation. It can be replaced by a new artificial lens, and thereby cataract is corrected. Okay, thank you. So guys, this is all about the human eye and the defects of vision. I'll be uploading more videos on my YouTube channel in future. Therefore, I would once again request you kindly subscribe to my YouTube channel and press the bell icon for notifications of the upcoming videos. Thank you.